All right. Well, it looks like we are reasonably stabilizing in number of participants here. So let's get started with our webinar on the new National Construction Code 2022. We're going to focus in this webinar on the changes that affect structural engineers in particular, and especially those that affect residential engineers, though we will talk about everything. My name is Brooke Smith, and I will be your presenter for today. So first, a bit about ClearCalcs. ClearCalcs is a cloud-based platform in which you can design any concrete, steel, cold form steel, or timber member, and increasing number of connections and foundations as well. Compared to other possibilities out there, we believe that we are more accurate because we have a full finite element analysis back end behind all of our calculators, meaning that no matter where you put your supports and loads, we're going to give you completely precise results. We help eliminate wasted time because you no longer have software licenses that get locked up by your colleagues, and we're available everywhere. So whether you're working from home, working from the office, or even if you want to take us on site with your iPad or even phone, you can use us on site anywhere you have an internet connection. Now, a bit about me. My name is Brooke Smith, as I mentioned. I am the head of engineering research and development here at ClearCalcs. I'm a chartered professional engineer in Australia and a licensed professional engineer in the United States. I grew up in the United States, and so my bachelor's and master's are both from there, but I've lived in Australia for about the last 5 or 6 years now. Prior to joining ClearCalcs, I had about 8 years of previous experience in structural engineering R&D consulting, mainly new product design, especially in cold form steel, and a research fellowship in the system behavior of thin-walled steels. And I was a forensic structural engineer where I specialized in reinforced and post-tension concrete. I have been with ClearCalcs now for just shy of 5 years. And now in the company, I focus on research and development and quality assurance in our engineering calculations. So one brief note of housekeeping. In your Zoom control panel, if you hover over the little bar at the bottom of your Zoom display, you should be able to see a little chat icon. And that will allow you to ask any questions that you may like. Please do ask it in the chat. And I'd also request that you ask it to everyone. So don't change it to just asking me because I may well lose track of your question. Please ask it to everybody. And then my colleague Chi-Ming here can also help keep track and make sure I don't miss any of your questions. And I will answer questions on the fly if I happen to notice them and they're easy to answer. But in general, I will save questions until the end of our presentation and answer them at the end. So today's agenda, I'm first going to give you a bit of an introduction to the NCC 2022, and then talk about the process of enacting the new NCC. We're talking about the NCC 2022 in 2023. So obviously it's been delayed, and I'll talk about some of the reasons behind that. We'll also talk about what's changed, and that's going to be the meat of this presentation, where I'll talk about what's changed in the document itself, as well as what's changed in some of the key revised standards that must be used now. And finally, give you a quick tour of how the NCC is implemented in ClearCalcs and how you can use the new NCC or continue to use the old one in ClearCalcs. So, as a bit of an introduction, the new NCC 2022 comes into legal effect in all states and territories on May 1st, 2023. So that gives you about 5 days. After that date, all new projects must use the NCC 2022. You can no longer use the NCC 2019. Now, Australia is great compared to the United States, where I grew up. The US may as well be 50 different countries, with every state adopting a different revision of the code there. Here, every state adopts the NCC on exactly the same date. However, one thing that does differ a bit from state to state is rules about how older projects transition. So I'm not going to go through those. Please refer to your individual state regulations as to if or how any projects that have already been started need to transition from NCC 2019 to 2022. So very briefly, for any junior engineers or any students on our call, the National Construction Code is the legally binding document that governs all building construction in Australia. Now, in most practical structural design, we're not actually referencing to the NCC itself all that often. We're usually referencing to AS 4100 for steel, 3600 for concrete, 1720 for timber, whatever. We're usually looking at those Australian standards. But vitally important, the NCC also sets the minimum revisions that you must use of the Australian structural standards for any of your design that you do. Now, enacting the new NCC 2022. Those of you looking at your calendar probably have noticed that it's 2023 now. The reason that the NCC has been notably delayed, well, one reason, like so many things recently in society, COVID is a reason. COVID led to meetings that the Australian Building Code Board was supposed to have being delayed. ABCB writes the NCC. It led to industry consultation meetings being delayed. It led to paper publications being delayed. Everything got delayed. But probably the more important reason was a lot of controversy that happened around increasing energy efficiency requirements in the new NCC. I'll talk a bit more specifically about those in a minute, but the key thing here is, I said the NCC is coming into effect on May 1st. Well, that's only most of it coming into effect on May 1st. There are 3 groups of provisions that do not come into effect yet, that will not come into effect until October 1st. Those are energy efficiency, condensation, and livable housing provisions. Those won't come into effect until October 1st, 2023. So those energy efficiency requirements are trying to account for both household energy bills as well as the societal costs of energy. Now, obviously, the elephant in the room for societal costs of energy is climate change, but that's also referring to just purely economic concerns as well. The more electricity people use, the more gas people use, the more power plants we need. So it is trying to control that as well. It's trying to control economic as well as climate change concerns. The specific things that are changing, the minimum thermal efficiency star rating, that's a 1 to 10 star rating, is going to increase from 6 to 7. Now, it's only a 1-star increase, but it actually does have a fairly significant effect. In the end, it's going to mean a fair bit more insulation required in houses, more control over glazing and sunlight and how that heats houses, more control over thermal efficiency in general in houses, and that is going to cost more money. In addition, there's a new whole of home energy use rating, which is an entirely new rating. It is out of 100. Houses, detached houses, will have to have a rating of at least 60, while apartments will have to have a rating of at least 50. Now, there are 2 ways to meet that whole of home energy rating. One is you can do a more holistic rating using the NatHERS software. That's free software from the National Housing Energy Rating Scheme, I believe. Don't fully quote me on that abbreviation, but that their software is free and you can use that to get a whole of home energy use rating. Alternatively, there are several just deemed to satisfy requirements, as I show on the lower right of the screen here, having to do with the building fabric you use, requiring ceiling fans in most warmer areas of the country, and some other rules around glazing and building sealing and some services and how they're provided to the house as well. Now, that energy use rating, just to briefly explain it, it's essentially meant to be a really high-level view of what the energy bills might be for a house. So it's going to be heating and cooling, plus hot water, plus lighting, plus pool and spa pumps. We're particularly highlighting those because those can be huge energy users, minus rooftop solar. So important point for structural engineers here, this probably means that a lot more new construction is going to have rooftop solar, because it can be a lot cheaper to just put some solar panels on the roof rather than trying to make everything else more efficient. So you'll probably see some more rooftop solar in new construction. Finally, there are some condensation requirements being added. These are somewhat related to energy efficiency. I'm not going to go into too much detail on them. They aren't too exciting. They're basically just saying you actually have to think about condensation and have a waterproof membrane somewhere in the building envelope. Now, the other provision that is coming into effect on October 1st is livable housing design provisions. Some of these are going to have some knock-on effects into structural engineering as well. This is essentially accessibility rules. So accessibility for less abled persons in our society. Those now have their own code, and key points that are now going to be required is you will need to have step-free access through one external doorway, which must be at least 820 millimeters clear width. Most internal doors into rooms, so basically excluding closets, will also need to be at least 820 millimeters clear width. That's essentially to allow wheelchairs through doorways. You have to have a toilet on the ground floor, and toilet and bathroom walls will now have to be strong enough to attach grab bars to them. You won't necessarily have to have the grab bars already attached, but they will need to be strong enough for that. You can do the calculations for that as an engineer if you wanted to, but there's some pretty simple deemed to satisfy requirements for just nogging locations or additional bits of plywood you can put on to meet that requirement. So that actually shouldn't be too burdensome, but that minimum clear width on doors may mean that some of your standard framing designs may need to have slightly longer lintels now. Now, other points that have changed for structural engineers in the National Construction Code. When you're actually looking at the document, and hopefully it won't actually need to that often, but they have a whole new referencing system that has been put in place. They have a little summary table that I copied here on the lower left. ABCB thinks this is clearer. I somewhat debate that, but at the very least, it is consistent across all volumes now. So volume 1, 2, and 3 of the NCC now actually all use exactly the same referencing system. They also have slightly easier access to the housing provisions document, and I can show that on the NCC website afterwards as well. We're making that a bit more prominent in the NCC. So in those housing provisions, while we don't actually tend to reference directly to the NCC that often, one time when we can is for simple structures that are fairly limited in scope. They do have some prescriptive requirements as well that can be made. So for footings and slabs, you can design using these prescriptive rules. The big change is that you can now only do so for class A, S, or M soils. So that's non-cohesive soils like sand and rock, or only up to moderately reactive clay. If you have highly or extremely reactive clay, you now must use AS 2870 or 3600. You cannot use the prescriptive requirements from the housing provisions anymore. Similarly, there are some prescriptive design requirements for masonry. That's clause 5 of the housing provisions. It's not been rewritten completely, but it has been significantly reorganized and expanded. So if you make use of those prescriptive designs in the NCC, that's been completely redone. Please make sure to familiarize yourself with the new organization and new rules in there. Structural steel section's been reorganized, and additionally, Class 7B buildings, basically warehouses, now have an additional load that must be included on the roof. It must have a 0.15 kPa load for solar panels. Now, why is this only for Class 7B buildings? Well, the philosophy here, and those of you who've had solar panels put on your own houses are probably familiar with this. Most roofs for most buildings are inherently strong enough, have some extra capacity in them. They can just slap some solar panels on them with no additional reinforcement, or possibly just some very simple additional reinforcement. So usually it's very easy to put solar panels on a roof. But warehouses usually do not have that extra capacity and are usually very expensive to reinforce after they're built. So now we're going to have a requirement right off the bat that warehouses have to have this extra capacity so that solar panels can be put on their roofs now. Now, some of the key points here are for standards that are being revised. So I'm going to specifically go through the first 3 on here and go through exactly what's changed in these standards. So steel design has some small updates primarily, mostly in adding a new bolt category and some changes to the fire design. That's all that's happened in 22 years. We apparently haven't changed steel design very much since then. Wind loads are a very significant update. So that has completely updated wind regions, has updated internal wind pressures, and a number of other factors as well. Residential wind loads is based on the 1170.2 standard. So commensurate updates have happened there. Talk about those. The ones we aren't going to go into detail on, but notably have also updated, AEST 1684.2 and 1684.3. That's the prescriptive timber designs standards that tend to have a little more to do with construction, but can be used for design as well. Those have updated to a 2021 revision that now must be used. Further, concrete anchors was an ancient standard before. It was last updated in like the early 90s. That has now finally been updated to reflect modern usage of anchors in concrete. So please make use of that. That's now a fairly useful standard. Masonry wall ties, so that's 2699.1. That's also updated to a 2020 revision. And any of you who do structural glass design, particularly in railings and such that may be supported structurally by glass, you have a new standard as well. Now, we're not going to go into the detail on those, but we'll go into the detail on steel and wind. So in steel, AS 4100 1998 has updated to a 2020 revision now. Biggest change is that there's a new bolt grade now supported. That's bolt grade 10.9, and that brings AS 4100 in line with the bolt standard, AS 1252.1. So we're finally adopting this new bolt standard that is available. There are a couple changes to the bolt capacity calculations, to the formulas for that, to reflect this new bolt grade, but this may affect some existing bolt grades to a small extent as well. In particular, the 10.9 bolts are notably more brittle, and so there's now a special ductility factor in the shear strength formula. Additionally, if you're designing slip restricted 10.9 bolts, there's some special friction considerations that you need to make in that design. I'm not going to go into the detail on those. Those aren't super common, but if you are designing slip restricted 10.9 bolts, make sure you read through that. And Finally, the only other real change that was made to AS 4100 was correcting a major error in the mechanical properties of steel at elevated temperatures.
Troughing the two front enders. Now, what will happen if
so there was a notable logical error there where previously it was implied that you were supposed to use the adjusted mechanical properties in the entire calculation for steel, including the slenderness calculations. That's now been significantly clarified with a new clause 12.4.3, which explicitly says that you should be using the mechanical properties at 20 degrees C at room temperature, the normal mechanical properties, for calculating slenderness. Everything else, you use the properties at elevated temperature, but slenderness has been calibrated to being based upon room temperature steel properties. So if you do any fire design with steel, please take important note of this. There's also an additional formula for G for the shear stiffness of steel that now adjusts for temperature as well. Now going on to wind, the wind region map has been updated. Please go and check the wind regions for any of your new projects to make sure that you know the correct region that you're in. There's a new region, A0, which is basically the entire interior of Australia. B1 and B2 have been split into two separate regions, and New Zealand regions have been completely redefined. Those of you who design in cyclonic regions, regions C and D, you may recall that there were some special F sub C and F sub D factors you had to use. Those have been eliminated entirely. Instead, what you're now allowed to do is you can linearly interpolate between the wind speed for region C and the wind speed for region B2, which is the next region inwards, based upon how close you are to the coastline. There are some specific rules about how exactly you do that and what distance to the coastline exactly means. Refer to the standard for that. But yeah, region C and D wind speeds have been changed, no longer have those factors. Recognizing the realities of climate change and wind effects that are going to result from that, there's a new climate change multiplier, M sub C, that is effectively going to give a 5% wind speed increase for the coastal north of Australia. So I believe it's regions C, D, and B2, where you now have 5% increase in wind speed to recognize that that's going to be one of the strongly predicted effects of climate change, that there will be stronger winds in coastal north of Australia. For terrain categories, we've now eliminated all intermediate terrain categories except for TC 2.5. Terrain category 2.5 has also been clarified to be essentially for developing outer suburbs of cities. So if you're designing any of those massive new developments in the outskirts of Melbourne or Sydney or any of the other big cities in Australia, you are now explicitly in terrain category 2.5. So you must design to that, even if you anticipate further developments to decrease or increase the terrain category as well. We've also clarified a couple of things on the shielding and hill multipliers, particularly saying that hills less than 10 meters, we're just going to ignore and say don't have any effect on wind. At buildings greater than 25 meters in height, we're going to say cannot be shielded at all. There is no shielding effect you can take for tall buildings. If you design any open buildings, there's a whole new factor for you to include for an open area / volume. And the net effect of that is basically going to be to increase the wind pressure slightly in small open areas, such as a veranda on a house, but decrease it for very large open areas. So if you're designing a big gazebo in a park or something like that, your wind loads are going to decrease slightly as a result of this new factor. And finally, internal wind pressures now are to take account of local and area factors for internal wind when you have one particularly large opening on a building. So particularly for warehouses, but also for garages as well, you should be taking account of these Ka and Kl factors, which might help, they might hurt too. They might decrease your wind load, they might actually increase your wind load in the structure as well. So take note of that for internal wind pressures. Now, those of you who have read AS 4055 carefully will note that one of the appendices in 4055 actually goes through explicitly how 4055 is derived from 1170.2. 4055 is essentially just making a whole bunch of conservative assumptions on the 1170.2 calculations. So everything I just talked about for 1170.2 is going to have an effect on 4055 as well. So really key one that I'll highlight again, check your wind regions. That wind region map has been redone. New wind regions and some existing regions have moved. There are also some slightly different net pressure factors to consider depending upon what structure you're designing in 4055. These also have a new symbol. It's now K sub C, combination factor, times net pressure factor. It used to be denoted as C sub PT. New symbol, same thing. But most notably, there's some higher uplift on open areas such as verandas or anything that's close to the edge of a structure. That's close to within, I think it's 1,200 meters of the edge of a building. So now I want to go through briefly what the NCC looks like in ClearCalcs in the platform that we designed. So I'm going to talk a bit about using the NCC 2022 in a new project in ClearCalcs, how to continue using 2019 in an existing project if you're able to and wish to, how you can use NCC 2019 in a new project, say if you're a forensic engineer and want to investigate an old building's design. And just a quick note on that as well. ClearCalcs will continue to maintain our old NCC 2019 calculators. However, we won't be adding any new features to them. So we'll still be maintaining them for any errors discovered, any bug fixes, anything along those lines, but we won't be adding any new features to them anymore. So they'll remain available indefinitely, but no new features. We will instead switch focusing on the 2022 calculators we have. So now, what does all this look like in ClearCalcs? I'll go to clearcalcs.com. I'll log in with my Google account. And first up, let's look at creating a new project. So if I want to use the NCC 2022, we tried to make this as easy and seamless as possible. If you just go to add new calculation right now, all these calculators that you see up at the top by default are compliant with NCC 2022. If I go and open the steel beam calculator, you can confirm this when you open it. You'll notice references AS 4100 2020. This is using the most recent version. All those old calculators for 2019 are still available. They're at the very bottom of our Add New Calculation screen under this Old Revisions category. So if you want to make use of these old calculators, you can. You can add them to any project you want. That is, we're leaving it to our users' discretion here. Can make use of them. But anything you select from the top here, anything that's not in this old revisions category is going to be compliant with AS 4100 with NCC 2022. Let's take a quick look at our wind calculator. In ClearCalcs, we've added an additional new feature which you can make use of should your organization desire to, where we are now showing you exactly the content of the standards. So you notice if I expand, for example, this wind region input that we have here, there are now buttons for every reference that we have. I could click on these. This is opening up exactly the standard AS 1170.2 right in your sidebar. So you don't have to leave ClearCalcs to go look at your standards anymore. Here's your map of New Zealand, your map of Australian regions. You can do this for just about any criteria that we have. You could go to our calculated tables, for example, and let's look at those internal pressure coefficients. I can click on the reference here, and here's the table that we're pulling all of our data from. So you can take a look at these standards. You can read all of the notes related to anything specific for these tables. You can see this table is now including KA, KL factors for large opening ratios in buildings. This can be available in just about all of our calculators. Any calculator that uses Australian standards, we now have this integration available. It does cost a bit of extra on your subscription, but please contact us. We can get you onto this new standards availability right now. We also have a standards library where you can go and open up either the new or old calculators, or excuse me, new or old standards. So I typed in 1170.2 here for wind. We now have our current standard, 1170.2 2021. You can also access the 2011 or 2002 1170 standards. And this will allow you to open up any part of the standard, scroll through it, review through table of contents. We'll be adding a search functionality very shortly to this as well. So you can search through the entire standard using a much smarter search than your PDF search. Will, for example, match, if you type in bending, it's going to match with moment as well. It will be smart enough for that. But anyway, going back to our NCC, if I have an old project, I can still open that up, and you'll note that I'm prompted for calculation upgrades. If there's ever a major upgrade that we make, you're going to automatically be prompted for this. If it's not a major update, then you'll be able to click on this. But if you see these calculation upgrades, we're never going to switch the NCC revision upon you. If you go through these upgrades, it's going to keep you within the same NCC. So I can upgrade everything in here in my old project. This is going to stay NCC 2019 compliance. So you don't need to worry about that. That will upgrade. It will stay as NCC 2019. And while that's upgrading, I'll just go to a different screen. And yeah, so we now have these standards integrated. Standards will apply also for older projects as well. So this is integrated with our 4100 1998 calculators, for example. You will be able to see that in the sidebar as well. And I guess one additional note I'd make here for everyone, we've put together a little one-page summary sheet that you can provide as a handout to your employees or anyone else, or if you just want to reference it yourself, for the summary of changes in NCC 2022 as they affect structural engineers. Everything is linked in here. You'll be able to click on a link here and directly open it up in ClearCalcs standards view, should you wish, or look at the NCC if it's directly relevant to the NCC and see exactly what's changed here. So we'll distribute this to you after this webinar as well, along with a recording of the webinar. And with that, that's all the content I have. So as I mentioned, we will send you a recording of this webinar by email after the completion of this webinar. Please give us a day or two to just process and edit everything as necessary. There will also be a survey at the end of this webinar. We'd appreciate any feedback that you could give us. on how we can improve our webinars in future. And if you have any questions that you'd like to ask us, send us an email at any time to either help@clearcalcs.com, or you can use the help button within the ClearCalcs platform as well. Next up in our Australian webinar series, we're going to have a two-part webinar on the wind standards for Australia. So we're going to go through, since these had some of the biggest updates in the new NCC, we're going to go through 1170.2, as well as a shiny new bracing calculator that we've just added to the ClearCalcs platform, as well as AEST 4055 and what changes occurred in that. So we'll go through those changes. We'll go through how to use the standard from start to finish. And with that, I'm happy to take any questions that anyone has. I've not seen anything pop up on my chat yet, yeah, there we go. Cool. So yeah, if you have any questions, please type them into the chat and I will answer them as I can. So first question is from John Burge. Do we have to apply 0.25 kPa as well as 0.15 kPa for solar panels? If you're designing a warehouse, yes. A class 7B building, yeah, that 0.15 kPa is in addition. It is on top of everything else. So the idea is, yeah, that is going to cost money on your roofs. That is going to make a warehouse roof more expensive, possibly by a fair bit. So they're often long spans that you have in those structures. That does only apply to class 7B buildings. Other buildings, the NCC has effectively assumed will always have enough capacity built into them to put solar panels on them with at least not too much additional effort. But yeah, the NCC is really focused on facilitating rooftop solar panels now, and that was a really big philosophical update in 2022 here. We want to facilitate solar panel installation on all buildings. Do we have any other questions from anyone on anything related to NCC 2022 or anything else related to the ClearCalcs platform, or just general questions you may have that I might be able to answer? I can't guarantee I'll be able to answer everything live. Yeah, question from Nick on most warehouses having inclined panels where the 0.15 kPa only considers dead load. What's my opinion on wind loads? I think that's an important point, that the 0.15, as you note, is not explicitly adding for wind loads on inclined panels. I think that was probably done over in response to pressure from industry, because yeah, it would be difficult to assess, well, what inclination are the solar panels that might be added in future going to be subject to, and a bit too much of an unknown for original design. I suspect the ABCB probably wanted to consider that. I was not in those industry consultation meetings, but I suspect they probably wanted to consider that, but just didn't because of pushback from industry. They were getting enough of already on everything related to all of their design, all of the changes in energy efficiency and their push for solar panels. That said, I guess what I would add is that flat solar panels on a warehouse roof are still beneficial. So I guess they are facilitating something that could be added in future, even if it's not the most beneficial of an inclined panel. Looks like that might be it for any questions that anyone has. I'll stay on for a few minutes for anyone else who has any questions that pop into their minds. Otherwise, yeah, thank you for attending our webinar today. As I say, we'll distribute the recording of this webinar, the slides from the slide deck here, as well as our one-page summary of changes in the NCC that you can make use of or possibly pass around to your employees as well. Yeah, thank you very much, everyone. All right, Chiming, I think we can wrap it up and call that a webinar.
Yeah, sure. Thank you, everyone, for joining us. See you next time.
Cheers, everyone. Bye.
Bye.